Hello friends, it's time for another API review. So today we have 3 blocking issues and then we will see what the day brings after this. At least the first 2 should be relatively quick. I don't think James is here because time zones and stuff, but I think I can represent this one. So basically what we have added is this requires preview features attribute. The idea of this one is that it's paired with an analyzer, so when you use APIs that are marked as such, you by default get a compilation error, and then you're supposed to change your project to actually say, yes, I would like to use preview features. And so the idea is that we can use this attribute to ship preview APIs in an otherwise fully supported RTM quality product and get a bit more feedback before we actually stabilize the API. So the problem with the attribute is that basically right now it's just a parameters constructor, so you don't get to do anything with the attribute, you just apply it, and then this marks an API as being a preview. And what James is suggesting is that we basically make it a bit more similar to how obsolete works. Obsolete has a message, so you can optionally say why the API is obsoleted. So in this case, we could say, you know, why is this particular API marked as preview? What is actually in preview here? And then the other suggestion that I had based on the discussion and based on the way he described it is that, you know, we should probably also have a URL parameter, so then when we actually report the diagnostic in Roslyn, we can actually use the URL parameter to surface that in Roslyn, which basically means in Visual Studio, when you click on the diagnostic ID, instead of just going to the generic preview featured documentation, it would actually go to whatever URL the developer put on the API. So this way we can, for example, have a landing page that is very specific to Kestrel HTTP3 support rather than the generic preview feature description. And that's pretty much it. So the idea would be URL is optional, so you set it via the property syntax. And message is also optional, but instead of setting it explicitly, because that's fairly ugly, we would just have a overloaded constructor where you can just pass in the message, which is also consistent how obsolete works. Are there any questions, concerns, or comments?
Cool.
Yeah, I've got a couple since you kind of closed there with similar to how obsolete works. Should we consider doing diagnostic ID and URL format similar to obsolete?
That's a good point. I didn't think of URL format actually. Yeah, so I mean, I thought about diagnostic ID, but I felt that maybe overkill, because the problem is also when we do that, I don't know how this interplays with our general infrastructure, right? Because the idea is that, now let's step back, right? The reason why we have a diagnostic ID on obsolete is so that people can suppress, you know, one set of obsoletions, but not all of them, right? The idea with previews is because we want previews to be viral, we generally don't want people to arbitrarily suppress certain things, right? So you could argue that, you know, we are violating this ourselves in the platform, right? Because we basically turn it off in particular areas to basically say, yep, in32 implements a preview interface, for example, but, you know, we don't want in32 to be in preview for obvious reasons. And so we only want the things that are related to the math interfaces to be in preview, right? But the problem with that is I think this is kind of intentionally to be a, you know, an expert level scenario, because it's not easy to say, you know, when is it safe versus when it is not safe, right? That's kind of something that a human has to determine. And I feel like as soon as we introduce a diagnostic ID, we would now have to probably add some rules that say, well, if, you know, if you put the attribute on yourself now, what diagnostic ID are you supposed to use? Because if you use a different one, well, then that may not play very well with the suppression for the other one, right? If you use the same one, well, then you may inadvertently suppress something, right? That's also not necessarily obvious. So I'm not sure that we ever want to do that, to be honest. And then I think if we don't have a diagnostic ID, then it doesn't make sense to have a URL format. Now, I will grant you that if we change our mind later and add diagnostic ID, then it's kind of sucky that we named it URL, not URL format. But we can probably just say, well, you know, if URL contains a placeholder, then, you know, we will use it. And no matter whether it's named URL or URL format, if we would ever add it later. Because it doesn't strike me as very likely that somebody has brace 0 in it, right?
And Frederick's right. You missed your chance to put your garbage carts out to the street.
Oh,
Yeah.
actually, I did this. I mean, it's 1 day and 15 hours too late anyway, but I already did it, so thank God my trash got collected.
I mean, we did talk back when we were first proposing this attribute. We did talk about being able to put a name of the feature on there and be able to opt into
Yep.
or out of individual features. And we concluded not to. We concluded that it was a global switch. And I think part of that. Yeah, so I'm wondering though if I'm trying to replay this conversation. I don't think we considered diagnostic ID at that time.
We did not. I think the reason why I proposed originally feature switches is so that you can basically, the idea was that the virality would be over the feature name, right? So that means if, let's say, in32 implements 2 preview interfaces, right, and one of them has the name X and the other one has the name Y, then in32 itself, if we would mark it as preview, we would say, well, this requires preview features X and Y. And so this way, basically, we can aggregate this up and say, well, this application really depends on X and Y. And so the idea was, or the intention was that if another developer later on calls, a third preview API and the app is only opting in for X and Y, they still get the diagnostic for now they start using Z. So the idea is that, you're not necessarily like marking yourself all up. Well, once you opt into previews, every preview feature is fair game. But then the discussion that we had was, well, if you think about how previews generally work, is that we don't really have that many independent features to begin with. We generally, try to deliver a package. And then within that package, these features tend to gel with each other anyways, in which case it's kind of weird if they would be disjointed. And then on top of that, the concern from the runtime team was, well, what's going to be the test matrix if we say people can turn things on and off individually, right? And to me, kind of the diagnostic ID would be reintroducing this to the backdoor kind of thing, because now you suppress half of them but not the other half. And that's why I'm not sure, because I mean, to me, the nice thing with the feature names was it was at least a formal definition of what it would mean. The diagnostic ID would be super gray area, and I feel like if we would do that, people would be able to shoot themselves arbitrarily in the foot now, which seems not desirable. I'm not saying no, I'm just saying I think unless we spend a lot more time thinking about what it would mean to separate the spaces into different IDs, I would not be gung-ho about it.
Tanner, what are your thoughts here on granularity? Is it worth further discussion, or is this something you feel like we're okay in?
I think it really depends on the exact feature in question. While there's both, I guarantee there's going to be at some point in the future where we have some feature where people want to differentiate it from the other features we've shipped in the past. And so maybe the diagnostic ID provides an easy way for us to do that today, where that's appropriate. We have at least 2 places that are using it today, however, being generic math and the system runtime intrinsics experimental, and they're very different features with very different with very different reasons why they are preview. And so at least on that perspective, it'd be worth having the 2, the granularity to differentiate between them.
So is the expectation that if we did add diagnostic ID that we can turn off like different parts in the analyzer? Because the diagnostic ID is tied to the analyzer itself. And adding that to the preview attribute doesn't mean you can suppress it using the preview attribute's diagnostic ID. I don't know if that makes sense.
It does, yeah.
Yeah,
Okay.
I mean, I think there's this general problem, which I'm not sure whether it's even possible, because I believe the way Roslyn works is an analyzer has to basically declare what diagnostic IDs it can produce, and
Right.
if you produce anything else, it doesn't show up. So the reason it works for obsolete is because obsolete isn't an analyzer; it's the compiler does it, and so the compiler isn't subjugated to the same limitation. So I'm not sure that an analyzer can actually have an open-ended customer configured ID space.
It can, because you don't report different IDs to the customer. You have some other opt-in mechanism, such as via the editor config, to be able to say, I have my own subset configuration switches that I'm aware of. And so, I can report CA 1000 to Roslyn, but I can have internal IDs that I can suppress myself or not suppress. And I believe we have at least one analyzer, or the community has an analyzer that does that for features. And of course, editor config directly supports exposing configuration options to analyzers, so you can flip switches more so than just enable disable.
I mean, fair enough, but that to me is not a diagnostic ID then. It's just some arbitrary metadata that is somehow attached to the diagnostic, and then you invent your own suppression mechanism on top of that. I mean, it's doable, but like I don't think it's the same as obsolete at that point. You just literally make up something else.
You're right. It's at that point now just a feature name.
Exactly.
Didn't we have some sort of feeling of staying within just the library space that once two preview features touched the same thing, now you can't describe why it's both things. So is that union, intersection? Like, what's the suppression mechanism? I feel like that's part of why it was just like, no, it's library. You're opted into runtime features and or library features and or language features, and those were our 3 levels of granularity, and everything finer than that was too hard to describe. I thought that was why we ended up with it's just preview and not preview and why.
Cool.
But you're still cool with the description then?
I mean, putting a description on things doesn't seem like it would hurt, but trying to tool it
right
is like, this is preview because it uses generic math. Well, it uses generic math and some other thing that's in preview, and okay, great, we remove generic math and we go to remove the feature, it doesn't compile, and now we update the description. Like, that's just a string. It's not there's not a tooling and a what preview features are you okay with, and it's you either get library preview features or you don't. Anything beyond that is just letting you know why you might want to flip the switch. Just text, not tooling.
All right, so then other questions I had here, Prashant, for both the message and the URL here, are those both things that can get plumbed through into the analyzer and surfaced into the build log properly?
Yes. The only thing to consider here is what happens if somebody derives, oh, it's a CO class. Okay, never mind.
Yeah, we generally don't let people derive from attributes that we want to tool.
Okay.
For the reason you were about to say. What happens if somebody exposes more data on it? It's also more expensive in reflection if you look up things by open-ended types, because now type checks are more expensive. But yeah. Cool. So that means I guess we are generally okay with as it is proposed then, right?
The one nit I'd say is the nullable on message and URL.
Mm-hmm.
Those would both be null.
Aww. See, this is the problem with like when you type into something that is actually not an actual code editor. Alright, so we would have message would be nullable and URL would be nullable. Yep, right. So that would mean it would look like this. No, don't want to attach a file. That would be weird.
And then if URL, or so if those things are null, I assume we use the message we were going to use in the analyzer before becomes the default.
Yes.
And then do we want a default URL that the analyzer shows?
The default URL should be the one that I mean, if we don't have one today, we should have one, which basically points to whatever documentation page we have for the diagnostic ID that we currently report.
Oh, makes sense. Just, yeah. So then gets treated as essentially the URL format to that diagnostic ID, not a specific AKA-MS
Right.
URL for this analyzer. Cool.
Since I don't think we're going to throw an argument null exception out of the string constructor, you should mark that parameter as nullable.
I guess. I mean, I don't. Does obsolete do that?
Yes.
Yeah.
Okay.
Null going in won't cause a problem, so we should
Yeah.
say
Oh, fair enough.
null can go in here.
Just get in the habit of putting question marks on everything.
When in doubt, question mark.
Yep, just put question marks absolutely everywhere, and then go, let's just turn the nullability feature back off, because it turns out references can always be null, no matter what metadata you put on them.
Okay, that's. I think that exceeds your snark threshold for the day. No, I think you have to say something constructive.
Oh.
All right, so then next one, I think hopefully is an easier one. Who can represent this one? I guess Leomi.
I will, yeah. Okay. So this one is about allowing custom converters to work correctly for dictionary keys. So a bit of background. Today, custom converters that are provided for types and input object graphs. I mean, for types that appear in input object graphs on serialization or deserialization as dictionary keys. Mostly like primitives like string and numbers cannot be used to handle dictionary keys. So this manifests today as a not supported exception being thrown by the serializer when the custom converter is provided for these types, and then the types appear as dictionary keys in object graphs. So the proposal is to provide API that overrides this.
Sorry, might I interrupt? I just wanted to point out that this is a regression compared to what happened in .NET 5 as well. The not supported exception being thrown. So this is the motivation for us doing this.
Yes, certainly. Yeah,
Sorry.
so yeah, for sure. So yeah, thanks. That's my next bullet here. So like exactly that's why I want to do this. So API proposal. So we have a couple of internal methods that handle this behavior in Serializer today. So this proposal is about basically exposing them with some minimal changes. So propose two new virtual methods, read and write as dictionary key, have the same signature as the existing read and write methods on JSON converter of T, except that for the write method we disallow now because dictionaries can have no values as keys. So do like the appropriate checks before calling the converter, but just like nullable annotation there. Some notes about the APIs. So just the first thing I said about not having null values, then we are proposing new methods because the new functionality assumes that we are reading and writing JSON property names. So that's the property name that appears before the value, like open brace and property name colon. So the left-hand side of the JSON key value pair only. So by adding new methods, we avoid users having to check the JSON token type on the read side, and they also need to write use the write property name for the dictionary key when they're writing. So these new methods can, as appropriately named, they can suggest like what the correct behavior would be or should be from users. So the other thing is that the introduction of these APIs mean that all serializable types can be serialized and deserialized as dictionary keys, provided that users provide implementations of the new methods. So like complex types like POCOs and collections not supported, although I think that is like pretty edge case, but there's no real reason in my, I mean, some people have asked to do sorry, I'm not sure if some of the questions here about in the chat are about this feature here.
No,
Eric.
it's not. Sorry.
Okay, never mind.
About the previous.
Cool. So yeah, so now complex types can be used as dictionary keys. I don't think there's any reason to limit that, and then also gives us some functional parity with Newtonsoft where this feature is supported. And the signatures are based on the existing read and write methods, like giving JSON serializer options, instances. I guess we could do stuff like honoring the dictionary key policy. That's say naming case for like your strings or like enum values. If you wanted to honor it that way. So I have some API usage examples. Scrolling down. So it's pretty. This converter doesn't do anything fancy. Just demonstrates like, the fact that we expect a token type of property name on deserialization, and then for users to write with the right property name on serialization. And so in this example, like rather than throwing not supported exception, like the custom converter that the users provided will kick in. So I think that this feature like provides a reasonable, one, it's like useful, people want it, and then it provides a reasonable mitigation to the breaking change that we talked about, where, and it's not too bad because users are already writing custom converters for the types. So it's not like they have to write new, like a lot of new code, just maybe a couple more lines to like get the previous behavior. So yeah, that's all I had for this one.
So to be clear, like the behavior break will still be there, right? It's just that we give people the opportunity to fix it themselves by effectively overriding those methods, right?
That's correct.
Laomi, can those methods be generalized by just saying string, like write a string?
Yeah, I think a more general name would be better, although, yeah.
And perhaps they could be used for quoted numbers as well, if that's the case.
Well,
yeah,
but for the write, the writer knows the difference between being in the property name state and the property value state. So you need to call write property name, not write string.
Right. So that's
really it's read as property name and write as property name.
Or I guess if we just had a method to return a string given a value, that might, then the framework can do the right thing. Write as property name, write as value, or read as string.
I see. So they give us a string and then we write according to what needs to be done.
Yeah, like a conversion type operator maybe instead of the raw JSON, at least for the write case.
So I have a question about the write method. Is there any chance, has it been considered that the method could return the string value that will be written instead of you having to call the UDF8 JSON writer, which could be doing arbitrary stuff?
Yeah, I think that was just very similar to what the previous statement. Yeah, we could do that. Just still thinking about it too.
Would we be missing out on any functionality if we simplified the signature here? So it would be returning string and just taking the T value and the JSON serializer options.
Yeah, I think that would work. That would work, and then the serializer will be responsible for writing the value according to the context. It's just that for like the quoted number scenario, we need to pass. It needs a special argument, the JSON number handling enum, which it can be fetched. We don't have the infrastructure to do it in a general way today because it can be fetched not just from JSON serializer options, but also from attributes. So we already have fetched that data when making JSON property info instances. So I don't think that even if we generalize it this way to return a string, that it can necessarily apply to like the quoted number scenario like directly. I think we'll still need to build different infrastructure to handle that because the signature will not be compatible.
Okay.
It will need additional information. Yeah. So, I mean, the reason to generalize would just be to generalize, like future proofing in a sense, but we still don't have like the concrete scenario where it would be applicable.
So I still want to understand, like the breaking change. We don't believe it's impactful enough to warrant just giving people the old behavior back in general. Because I mean, if you have to call different APIs, that means nobody's code, unless they do something, will.
Yeah, I mean, I was
magically
about to
work.
ask him what's the upgrade, because if we're turning an exception into you can write a new override, that's a breaking change, and
So-
like that's not good.
Yeah, the reason why, like, so I considered just like forwarding to the built-in converters, just like detect the T and figure out what's the, like what we used to do. But now with source generation and the efforts to reduce size, like would have to be, I don't see how we can do it without like referencing the converter statically, which increases size. We'll have to be like, oh, string converter, int converter, like, and that will affect a bunch of apps that don't use those converters. So I don't know that there's a good way to do it without like regressing size.
I mean, isn't that what one of the examples where, I mean, if I don't use a source generator, why should my code be regressed? I think it's reasonable to say if you do source generation, maybe that's one of those things where, sorry, we can't do that in source generation. I mean, that would be unfortunate because every discrepancy will add up over time too, but I mean, I don't have a good handle on how impactful that breaking change is, but I don't know. In general, it seems unfortunate to make a breaking change and then tell people like, oh yeah, you can get the old behavior back if you're willing to write some code.
It was sort of important breaking change we had to make just for things to function correctly and be linker friendly. So that's like why we made that change in the first place. And then my thought is that the mitigation isn't too bad because you already, like, you only experience it if you have a custom converter. So
Right, but so the problem is if somebody's written a custom converter and put it in a YouTube package, in a NuGet package, that's already out there. Now some other library referencing that, they're now broken. Right? So if you have to override this to function again, then you need to back out your feature because you've broken someone. Like, you can't make existing converters not function with the new version of the package because they're not necessarily in the application that chose to upgrade.
yeah, I just think that like at this stage to reverse it, it's just like we're sacrificing.
Yep.
And just to clarify, I mean, we said this is regression. However, there was a bug. You can call it a bug in 5.0, or we just didn't call it custom converter. We just called the default one, and now we throw. So I mean, just to clarify.
And people could argue that, well, I guess that they want their custom converter to kick in for those types. I'm not sure if would have been a regression to go from the framework handling it to pushing. Yeah, it still would have been so. It's maybe more of a bug fix than.
Right. So it's just if somebody has to override this new method to get back to a functioning state, then that's a problem. Like the virtual needs to work. Like if you can do it where the virtual can just work, then it's cool. But an existing NuGet package, we can't say, hey, we've published the version 6 version of system text JSON. Anything that published a converter using the version 5 can't work. Like it will break. Why? Because it needs to override a method that didn't exist. And that's a bad state to be in.
So yeah, so to avoid that with the virtual working just means we have like 12, 13 built-in converters that are now always rooted for all apps that use system text JSON, which I don't think is worth the backward compatibility.
I mean, for what it's worth, that's currently the behavior in 4.NET 6 for the last few previews, and this proposal is merely providing an escape hatch. So the alternatives here are either provide the escape hatch and keep the breaking change, or revert the breaking change and route all the default converters, which we explicitly wanted to avoid.
I mean, this is why I said, like, I don't have a good handle on how impactful their breaking change is. It seems you're believing that the impact is low because it's a fringe case. Can you explain a bit more why you believe that to be the case?
Sorry, go ahead.
No, did you want to?
I personally don't think it's a fringe case. I think many people override the string converter for reasons that are probably not great, let's say. But as a side effect, all these people will get not supported exceptions should they need to deserialize something that contains a dictionary with string keys. So that would be a fairly common scenario in my view.
Yeah, I think that if we were going to make changes like this, like it would be like now, I think we were writing the serializer with somewhat different goals in the past, like where a lot of dynamic functionality was working, and then we didn't really care about size and things like that. But like now we've gone through like an exercise, like figuring out how to write the serializer in a way that.
I kind of agree, but I kind of disagree at the same time, because the problem is that we know that people treat .NET as a super dynamic system, and that that doesn't play well with some of the goals we have. We know that, but like the problem is that in many cases people legitimately don't care about size, because if I write an ASP.NET web app, I'm not very likely to use trimming in the first place. So like, why would I have to, like, why does my app regress because somebody might use the same technology to build a mobile app where that's super important, right? So that I feel like the trade-off is that we are regressing a scenario where the gains are not visible to the customer, and I don't have a good handle on how impactful that is. But I mean, I would say if it impacts anybody who has a dictionary, regardless of the type of the key, then that's bad. If it only applies for if the key isn't a string, then maybe that's okay, maybe because maybe that's rare enough. But like, if the thing is a string, it probably should just work out of the box.
Yeah, we can special case the string converter. Like that was the initial approach, just special case that one. It's one converter, and I think that's the most common case. And I think it'd be rare to have object graphs that don't have string in the first place. So even if we read the string converter in all cases, I think that might be.
Does any?
Okay.
But sorry, when was this breaking change shipped in 6? Was it in the earlier previews?
I think earlier previews. I did make a note saying when I merged the PR that made that breaking change, I will pursue this feature as the workaround. So I guess that's why we're here now. But it was earlier in this release.
Have you received any feedback on this? Did anybody complain?
We did. Yeah. So one guy, which was string, which was for like a string converter, we're trying to do some Unicode transformations on the string. And I imagine that he would want to do the same thing for the dictionary string keys. Well, I mean, maybe they were not broken in 5, so maybe not. But yeah, we did get feedback around this. But again, everybody seems to agree that string was the important scenario here, and not like.
I mean, I think I'm okay with saying, we break the 1 in 10,000 cases case, right? And say like, yeah, sorry, we do this for simplicity and source generation, even if you don't care, but we think it's fringe enough that, if you care, sorry, you have to write 2 lines of code, right? But if we say, sorry, like you do the super common thing in ASP.NET and you can't have it anymore because mobile, that seems like a weird message, right? That's I mean, it's not to say that we never trim ASP.NET apps, right? But it's fair to say like not in the 6.0 timeframe, right? So I feel like even if we have trimming, I mean, I think the more dynamic the system, the more babysitting we expect from the developer, and it seems, given how dynamic ASP.NET apps are, I don't think this will ever be free of babysitting. So I think it's okay if those people have to do trimming, that they would have to do some work, right? So it would be okay to say, sorry, once you move to .NET 8, where we have first-class trimming support for some of the stuff, what happens to work for you today no longer works, right? But if I'm not trimming, then why are you taking something away from me, right? That's I think the thing I'm struggling with.
Yeah, I mean, to me, the real difference, like, I'm okay with a major upgrade breaks an application. That's fine. You move forward to a new version, something's different in your application, and you move on. The problem with this one is it feels like it's really set up for this goes across the NuGet package boundaries of you and your application, you wanted some feature from the V6 version of the serializer. Now some NuGet package that you were talking to, you just literally cannot use. And now you need to go hound them to go upgrade, to go do a split compile so they can, in the .NET 6 version of their thing, see that there's methods here to override. I mean, I guess really this is all the net standard, but so they need to upgrade their package version to see that there are the new virtuals to override to get back to the functionality they had previously. So this is the good old, you need all of your dependencies to have already updated the day before the platform shipped. And that's where it gets weird.
Yeah, I think in general the problem is that it's very attractive to think of library space versus application space, but it's not. It's similar to exchange type, right? It's not like a binary thing, right? It's a very fluent thing that kind of depends on the concretes, right? So it's just a mental shortcut for us to like put things on a spectrum, but we have to understand that what is an application scenario for one customer might be a library scenario for another customer, right? So like it's
Right.
always, you know, somewhere on that spectrum, right? And
That's why I always view it all as library problems.
yeah,
So
but
I think what broke this, I think we just need to back it out and put it in the next version.
I mean, what is fair to say though is like it's not a platform problem, right? Because it's logically a NuGet upgrade problem because the NuGet package is provided already down level for Net Standard 2. So logically, if you upgrade your NuGet package, you can write the correct code now, even if you still target the older platform. So it's not like you have to now say if dev older platform, don't do the override, if newer platform, do the override, right? So at least you get to write one set of code that, you know, keeps working everywhere, right? But it certainly is a problem if you think of the upgrade experience where somebody just retargets from .NET 5 to 6, didn't use the NuGet package, and from their point of view, it is an upgrade issue, right?
I don't think if you have this, if you're running on 6, you can't even force the downgrade back to the 5.
No, that's not what I'm saying. What I'm saying is that the problem for platform provided functionality, let's say in system runtime, right? If we do a breaking change like this there, the problem is you can't write the code that works down level and up level, right? You now have to special case it. Here you wouldn't have to. You could just say you can use the newest version of systemtext.json on .NET 5, right? So there's a path you can take where your code works everywhere, but it does
right. But it
people to
requires that everyone who currently, and maybe this number is 0 and it doesn't actually matter, but it would require that everyone who currently has a custom converter that gets used in a NuGet package or published via a NuGet package, that they immediately go out and grab the new version, override these things, and they do that before anyone uses their library from a .NET 6 runtime, because from the .NET 6 runtime you can't downgrade back to the V5 functionality because it's part of the platform.
Do we typically think that like such authors like proactively look out for like release notes and updates and like breaking change notices? Is that
my view of seeing things on NuGet is it worked once, I hit publish, it's there. And when enough people complain about a thing, maybe I'll fix a bug. That, you know,
I mean, people tend to be reactive, right? I mean, it's also true for us, right? We tend to throw stuff over the wall and then we consider it working unless people scream, right? I mean, if you have enough customers like us, I mean, once you have hundreds of thousands of downloads, if nobody complains, it either means nobody uses the feature or the feature works for everyone, right? Like that's probably fair, but that's why, I mean, that's the problem with previews, right? So if we have had 0 signal on the previews that the breaking change impacted anybody, well, that may just mean that the previews haven't been adopted broadly enough, right? But like if we have received some amount of feedback on the previews, then I think it's fair to say once we ship stable or RC, like it will get worse. So the question is, I think for us is like, how strongly do we believe we need to take that breaking change? And do we really believe there is no way to make this just work? Because the problem that we have is that we have both first parties and third parties that heavily depend on this functionality. And so if we break serialization, that's usually pretty bad because it's customer data that might not read the same that it was before. And if you think of Cosmos DB, I mean, you put your JSON document into the DB, you read it back out, and well, something changed, and now you get different behavior, just throws. Many people will consider this an upgrade non-starter, right? So that's why I'm saying, to me, it really depends on how how strongly do we really feel that this is necessary? That would not be a breaking change I would do very lightly. There's some other ones where I'm like, yeah, it's fine. It's a one-liner change. It's obvious what the correct behavior is. But messing with serialization data seems impactful and hard for the customer to reason about and fix. Especially when you consider library boundaries where you are not actually the person that has to make the fix, right? You're just an app that uses Cosmos DB. They own the converter. They didn't override them, and now shit stops working for you. And you're like, oh, what the heck do I have to do now, right? And so I think that's kind of the challenge where if people, I mean, yes, when everybody upgrades and everybody uses the new functionality, it's fine, but there will be this moment after 6 ships where part of the people are compiled against the old, part is compiled against the new, and then stuff doesn't gel, right? And then everybody's bitching. And then the problem is, at that point, what do we do, right? Because, I mean, if we fix it now, we break people the other way, right?
Because the mentality, at least that I think we generally suggest people have, is if you are a library component, that you target the lowest version that you can of the dependencies that you have. So a library component with a converter may be targeting, the 3 or version 3 version of the package, because they're like, this is the most compatible with the universe. I'm not forcing anyone to upgrade. But now it's literally all versions prior to 6 would be obsolete, because you need to use 6 and override this function, or you've had a regression in behavior.
So going back to the requirement, the person that's asking for this, do they need their custom converter called, or is the old behavior where we just call the built-in one sufficient?
They're fine with the old behavior, and it's for string. So, and I do think that string is like the dominant case, even from the feedback. Like, we didn't seem to care about the other types. But yeah, they were fine with the behavior of the built-in converter handling it. If we make the change and then route that converter for string, they'll be fine. And then because it's virtual, if they wanted to provide their own logic, they could override it and then also get the new behavior. So,
to be clear, we did discuss mitigating for the case of the string converter, and we speculate that this would address 80% of use cases, but that does not make the problem go away. For every other thing that can serialize as a dictionary key, the issue will remain. So the question is, do we just do it for string, or do we revert for every converter?
Yeah, and so now that that's come up, we can talk about a specific point that's confusing me. If this is to allow, or is part of a pipeline that lets a dictionary of int to whatever work, how is it that the signature for write as dictionary key takes string? That means we've already done a transformation of int into string, and I thought that's what the converter was supposed to do.
It doesn't take a string.
Oh, it takes a T.
Yeah, that's a T. Yeah.
And just because we're on JSON converter of string here, that it says string. Okay. All right. Never mind. That makes a whole lot more sense.
So it seems like we should push this back to needs work. So I mean,
I should point out that this API proposal is highly orthogonal to the breaking change we're discussing. We could ship this regardless of what we do with the not supported exceptions. And in fact, I don't see any reason why we shouldn't be adding this.
Yeah, so this will be my next question. So if let's say we undo the thing, right, and we basically now say, yep, we get back the old behavior. My understanding is that means that we regress effectively the source generator. Are these methods effectively a way for the source generator customer to allow better linking by using those overrides?
Yeah, because if you just specify their custom converter, the serializer is not it's not like referencing them directly. So yeah, we undo some linking size efforts, like most of it, if we don't do it this way. And if we ever wanted to go back and then size became like a thing that was important to a lot of people, I don't think that we're able to do this without things like linker feature switches that say, hey, disable things. So it's not going to be as clean in the future. And that was something that we considered for SourceGen in this release that we didn't want to do, make it based on a linker switch at this level. So just talking about the implications for size in the future if we decide to like put everything now.
I mean, I like that model. And that model, basically, the idea is if you compile against 5, stuff works on 6. It's just less ideal in source gen. If you want things to be more ideal in source gen, you should override those methods. If we wanted to ship an analyzer that tells people to do that, and then I think that would be a good model. I think that would be a good API then.
So what was sorry, I think I missed what the good thing was.
Well, the good thing is that basically we don't regress customers, and people that care about source gen, they can tweak it further to get into the footprint that we want. And so it's kind of pay for play, right? If you don't care, stuff just works. If you do care, you can make it better, right? We don't have to accept the regression, basically. And we don't have to accept the size regression either. It's basically people that don't care about size, old code just keeps working the way it is. People that do care about size get to get better size results by overriding these methods. And
yeah,
then,
I mean,
and I think in the long run, the ideal would be we would ship an analyzer that tells people that extend JSON converter, please override these things. So if your stuff is being used for dictionaries, it also works great.
I don't know that the linker will trim out like the parent virtual method just because you were like, is that, sorry, was that like a thing that were like
well, that was kind of my
or?
question. So like if we provide these APIs, does this and we do undo the regression, is it then fair to say that the customer can get the size benefits by additionally overriding these things? And my understanding based on what you said was yes. If the answer to that is no, then that's not good.
The answer is no. I mean, Eric here maybe to correct me, but I don't think the linker will trim out the virtual parent method because it doesn't know that every converter does that, basically. So it will still leave I think the way that it works for linking in the future is with linker switches, which is where you specify like a property in your CS project saying like, so JSON source generation. And like, again, we didn't do that because like, it's harder to tell when things work and when things, like why things fail. Like,
right.
If the library or like if it's the library author that specifies it, that affects like the apps and the user scenario. So I think it just like sets a messy precedent. Like if we start relying on like like in different programming module that involves linker switches than just writing the source generator, like the serializer in a way that is like trim friendly as a first class like architecture. So no, yeah, just final answer on that is like no, like this approach will not be linking friendly if we root everything. Like so, but I do think that we string just like 80% of the cases, or roughly that will be mitigated.
Okay, so then I guess I'm back to square one then, because Eric made it sound like this is an orthogonal API, but then it seems to me we should still think about what, is there for us a way where we can say, we can undo the regression and still have a way for people that do source gen to basically get better results? And if these APIs wouldn't work for that, is there maybe a different API or a different path we should take? Or do we just already know that this is not workable?
I do. Maybe it's worth it to see whether there's a way we can register the converters in a different way. I think the breaking change that pushes the responsibility to the converter is the only way to do it cleanly for the source gen scenarios. Basically just allows source generation to work for dictionary cases in general, like not just string, but the way it's written is such that it can like source generation can support dictionaries. So I think the breaking change is fundamental to that functionality working. But whether we can register the built-in converters for this specific like scenario in a different way, like in a like somewhat loosely bound way that doesn't write them explicitly, I don't know that it will work, but I think like I'll be willing to say come back on Thursday and then give an answer. But
in the old world, so .NET Native, we had the XML file that you could edit that said keep this type alive even though you don't think it should be. Do we have something like that with the current trimmer? Can we make an app that wants trimming have to go register all the internal types for non-elimination? Like,
We don't like that model. Like that model, at least in the .NET Native world, doing that was error prone like crazy.
Yeah, the problem with
Sure.
that model is if the linker is more aggressive, then your confidence that your app works is lower, right? So that's because you basically have to execute every path in your app and make sure that nothing blows up with, sorry, this type got trimmed out, right? Or
right. Well, it would be the virtual, if the virtual looked up the type via reflection. So that if the base member of this new virtual, if it had a complicated go look up a type by reflection and trimming could have deleted it, then that lets apps that did the override not need the type or not need all of the converters to be rooted. And then if you did turn on trimming and you did use a library that didn't override one of these, then if it gives back a good message, then now you have the like, okay, go rerun the trimmer with this type registered. And
yeah, I mean that's the thing that we learned from .NET Native, that people really hated that model.
Indeed.
But I mean, like this actually is how we do like some of the other collections, right? Like stack. Like the serializers are all marked as unsafe already. Like the reflection based serializers, they're all marked as unsafe already. So kind of all bets are off that it's just going to work when you turn on trimming. So this could just be, if I'm understanding the proposal correctly, like we have a weak reference to a type. And if that type happens to get in the app, it works. And if it happens to get trimmed away, it blows up. But the only way it could have been used is because you called it through an unsafe API. I think that's fine. Again, we do the same thing for other collection types.
Because yeah, I'm like personally, I'm fine with trimmed apps being broken. It's people who had existing applications that get broken by a transitive version dependency is what concerns me.
I'll just add one clarifying phrase to your statement. Trimmed apps that produce warnings, them being broken is totally fine. Warnings, right? If we've already given you a warning because you're using the serializer in reflection mode or whatever you want to call it, those being broken for all sorts of different reasons, that's totally fine.
Yeah, so I'm saying where my the behavior of assuming that the virtual here is a throw of you need to override this to get the scenario working again. If that happens to only throw for trimmed apps, that reduces my breaking change impact feeling.
No, it doesn't.
Right. The non-trimmed apps are the ones that I'm concerned about.
Yeah, just my own personal, somewhat stance on it is that if we in just final time, if we root the string one, then I think that it's not going to be as impactful. And the few people that do it, it's unfortunate that you might have to update their code and release a new version and things like that. But I don't think there will be a lot of cases.
Yeah. So should we? Eric T. Asserted that the API is independent of the feature regression.
That's right. Yeah.
So maybe we should look at the API. Can you scroll up so we can see where all the T's are versus where the strings are?
So as proposed, you just write the value as a string. But there was a suggestion around returning a string. But I don't know that it doesn't. Doing that doesn't necessarily apply to the other quoted feature, which is quoted numbers. So I don't know that we have to do it that way.
Well, But you do have the problem, because when you call the thing that's currently called write as dictionary key, if you're in an object and you're in the property name state, you can't call write as string. You have to call write property value or write property name. So you need to call the right method depending on where you are, and only the serializer really knows what state it's in. So returning string is more flexible because you could do the same thing later for quoted numbers if you wanted. And then otherwise, if we wanted it to be quoted numbers in a value as well as quoted numbers in a property, now we need another method to talk about the fact that we're in a different state. And the only difference is what's the line that you call on writer.write.
Yeah. Okay, that's fine. We can return a string here. Quoted numbers needs more information than we provide here, which would be like extraneous if we provide it here. But it's fine to return string. That's cool.
And then, yeah, so then the writer can drop out of the signature.
And we could do the same thing for the reader as well. Just accept a string parameter at return t.
If we, I mean, passing the reader allows you to process the data as bytes directly and not have to materialize a string. And even the same case for the reads for the right side, actually, which is you don't have to materialize a string, you can just write some bytes. So I guess there's a performance benefit for doing things this way.
Fair enough. I guess one downside of passing in the full-blown writers and readers is that we would need to guard these calls with some sort of validation, as we do with the regular read and write methods. But I mean, I hear that point about not materializing the string.
Fair enough. So I don't know what we've done in the rest of the JSON serializer space, but for the reader, we use JSON terms for things, right? So it's write property name. Should this be write as property name and read from property name?
I was considering, given some feedback from a community member in the issue, that maybe we should just call it write to string and read from string.
But again, the problem with that is it feels like it also applies in the value side, and this is literally only for JSON property names.
I mean, assuming that we keep the current signatures, and indeed most implementations call writer.write property name, then we should keep that name, write as dictionary key or write as JSON property. But if we're not doing that, if we're just returning a string, then we could call it write to string.
Yeah, I agree. But I thought that there was already the pushback to leave it as writer, or taking the writer and being void.
I kind of assumed that was only the case for the reader method, but.
Yeah, according to how I think this, I think property name sounds okay to me because.
So I think I kind of missed something. Are we in agreement that we'll be passing the writer and the writer and reader instances in both methods, or just the reader method?
I think both methods both methods, because we don't have some materialization.
Okay.
If we think we ever want a general mechanism to convert to a string, it might make sense to have a separate method for that. But maybe we should just take this offline and come back on Thursday.
Yeah. I mean, because the problem would be if you have, write as string and write as JSON property name, like, is one of them calling the other? Is that reasonable to do so in a later version? Like, you have virtuals here, and that's the most complicated thing you can do in .NET is be virtual, especially once you think one virtual might ever want to call another virtual, because once you've once you've written that order, you can't change it. So I think with this, that really with something like this, there's not a maybe we want to in the future. It's you kind of really need to have your final plan before you start.
Yep.
I mean, it's not totally absolute on that, but it's for best results, design everything and then see what you can do incrementally. But thinking in the future we might want to blank means you probably have a reason why it's not going to work.
I mean, we already have the internal infrastructure for the quoted numbers case, so I kind of know what that would likely look like when if we want to expose it. And that's why I know that I'm thinking that there's no direct overlap, because I did try to write implementations in a way that's shared, like they can call each other and things like that. We might call some common logic in some cases, but like as far as like the scenarios which they applied, I think it's good to think about it and come back. But
right, well, because my concern would be if whatever you said the quoted numbers would need things that are not currently in the signature, and if that's the case, then now if you have a dictionary of int to whatever, then now is there going to be another virtual for writing the property name that has the extra parameter in case you were an int? And if that's the case and you're doing it next version, I would say no API in this version and just do the whole feature together.
So in this example, we said if I have like int to something and then also want to apply quoted numbers.
Yeah, the thing that you're trying to do is if your key is 1024, you write 1,024.
Yeah.
Then
so that's on the left hand side. So we'll call the method for that. Then if you had like a number you wanted to write as a string on the right hand side. Then
but you said it would need more information than the signature currently provides.
No, not for the property name scenario. Like it would be for the property value scenario. So you know what the number handling setting was, like write as string or allow what do you call it? Named floating point constants. Like so.
But wouldn't that be the same in the property? Like if your dictionary of float and you want to write down the string PI?
Yeah, you just need to write. I don't think there's any like special information you need there. Just write that float as. I see the feature of how I don't know that. Well, with the current number handling like values, there's nothing like more special than just writing it as just adding quotes for the most part. Like there's no like, hey, drop trailing like zeros and things like that.
Well, so my statement is just maybe I misunderstood that for the custom number formatting thing that you would need to alter the signature of this method. Because if it's something hanging off JSON serializer options, then it's fine. You have a natural upgrade. You can get in here. You can see that that things are supposed to happen, and you move on. If you need to alter the signature or make a new virtual, then that concerns me that we would add this right now and immediately have a more complicated version of it in the next version.
Yeah, I think the number handling feature, as I understand it, or as a reason about it, applies to just property values and not property keys. Maybe it's cool.
But it again means that we have a half-written feature, right? You have the custom number handling as long as it's the value, but not as the name. But we just added support for doing a custom converter, modifying dictionary keys. Like this is again, the feature is not playing with each other.
Right. That's why I think we just need the general string conversion, and then the serializer can do the right thing with those values.
Right. And
okay.
And the drawback is you have to manifest the string, but
so, I mean, given that we discussed this now for like 45 minutes, it doesn't seem like we will come up with a design in here. So like, let's maybe just push this back. You guys think about it, and then we can either do Thursday or next week, depending on how fast you can come back. Because I feel like the other one that we want to look at here is probably also quite large, right?
Yeah. Okay. Thank you. So I guess for this one, I We have reviewed source generation APIs previously, and since then. Sorry, Imo, can you switch to the new issue?
Well, let me first post the notes for this one here. So,
Oh, sorry.
Yeah, I've just make sure that we have the right ones. And we should consider a general to-string conversion so that the serializer can do the right thing. Does this capture what we said?
Yeah, that looks good to me.
Then let me post this, mark this as API needs work. I leave it blocking so that, you know, it's not done yet. All right, so.
Okay, so we looked at source generation APIs. So there's like, if we can scroll to the bottom of this issue, I mean, like the last comment here.
Sorry, the last comment. You mean the last?
All the way
point?
down. No, just all the way down. Yeah.
Oh, comment quite literally.
Yeah, last comment.
Oh yeah. Okay, here we go.
Yeah. So we've reviewed source generic APIs, and since the last time we looked at this, I've been adding functionality to the source generator, just like, and then now it's just adding some functionality and building the features that we need. So now I wanted to come back and then review like the changes, and most of this is already prototyped in the runtime. I wanted to come back and then take a look at the new APIs and then and just get them like reviewed and assessed. So if you scroll down, there's two classes of APIs, like source APIs for source generator to use, like the source generated code that initializes all the type metadata and like and sets like the serialized logic and things like that. So that's this set of APIs. So this diff here where we're adding a few structs is rather than passing all these values as individual parameters to some create methods that create this metadata, we encapsulate them into a struct because it's cleaner than having like 14 parameters in the method, and also helps with the issue of forward compat in the future. Like, hey, what if we add a new feature? We can add the metadata to represent that feature in these structs in a non-breaking way, rather than having to add a new overload of like the create JSON property info method, for instance. So these are just supposed to just contain values that are set once by the source generated code, and they're read-only, like they're not supposed to be mutated, and then the serializer receives this information and initializes the metadata as required. So it's pretty much, most of it is the same things that we saw last time. Just a few things were added, like things saying like, is this a property? Is this public? Is it virtual? What's the declaring type? The type info for the property. So all this list. I think the only thing maybe I've added since last time is the stuff about public and virtual. That just helps us like honor things like not supporting non-public members, and throwing like relevant runtime exceptions when people do things like add JSON include on a non-public member, which should be like an exception for now since we've not started supporting that. And it virtual helps with things like like collisions between property names, like at a derived class versus a base class, and this has to be like collisions need to be detected at runtime for the metadata scenario, because like things like the naming policy applied can force collisions. So we need that information. So just little background about some of the information that we need here. This extension data property is like another one that we added here, just so we know like whether to set overflow properties in this like particular property that you're specifying. So I guess scrolling down to JSON object info values, a different struct. So this here is information that we need to create a type info for a type. The first thing we have here is, and most of this is things that were represented in like the overloads to actually create the JSON type info instances. But so like create object func, like how to create the object using a parameterless constructor. Another func below that to create, this needs to be renamed to like create object func with parameterized constructor or something like that, which allows you to create with the parameterized constructor like a func that we can call easily to initialize property metadata, a func that we can call easily to initialize constructor parameter information, what the JSON number handling for the type is, and then a serialize func that contains serialization logic. So the create method will figure out like what is the, like we'll do some analysis on this input data to figure out like what information is needed or not, like when to throw exceptions and blah, like things like that. The next struct here is JSON collection info values, which specifies information we need to create like type info for collections. But how do we create an instance on deserialization? What is the metadata for the key? What's the metadata for the element type? Which kind of relates to the conversation that we had previously about custom dictionary keys, somewhat. Then what is the number handling, setting, and serialize func? So a few common things to the previous things, but I don't think that we should like introduce interfaces and things like that because I don't think it's necessary. Then scrolling down, we have JSON parameter.
Real quick, there's a CTOR in the name there.
Yeah.
It is used in a few places. Generally, when we refer to things like metadata, it's not we don't generally tend to shorten it to CTOR within like the reflection stack. We only tend to do it when we're talking about like cracking open ECMA stuff.
Well, I mean, I would generally say the names are not great right now because, I mean, also the func suffix isn't great either. I mean, yes, the type is called func, but we generally don't call things funcs.
We do sometimes use the action suffix, so we could call that serialize action. I know ASP.NET does that in quite a few places too.
Yeah, I think the normally we call it either handler or something like that.
I think calling it action would confuse it with actual system.action.
Yeah, handler and callback are the usual words.
Yeah. Because I mean, it doesn't really matter what the type is, right? Func or action. Like the point is that it's an interaction. You basically have to initialize it to a method that does the work, right? So I think callback or handler seems to be more sensible.
For sure. Then so we should do a pass at the names. The JSON read-only so we have the JSON parameter info values, which stuff like default value has default value, name, parameter type, and position. Just information that we need to be able to like initialize constructor argument information. So if you look at the diff here with the partial class JSON metadata services, so basically we're deleting the overload. Well, we're changing the signature of the overloads to go from taking a bunch of those parameters to just taking the struct instance. Similarly for JSON property info creation, we instead of taking like its boolean, its property is public, blah blah, then we just take the struct. Then we can scroll down a little bit to the collection type info creators. So the first three here are the collections that we supported during the first pass of API review. So array, dictionary, and list. And then I said I'll come back with the rest. So similar, we instead of like all these long parameters, we just take a JSON collection info. And then for the other types, most of them have the same like signature. Just with the immutable collections, we also pass in like a create range func, which follows the create range pattern, which is what yeah, so we take a create range func which allows us to like create a temporary list and then copy something behind me. But okay, so yeah, so create range func, and then finally create stack of view info just takes like the very last method here takes a like delegate to an add method like push or enqueue, so you can add to the collection, and that's pretty much for the creating the collection info. So similar to like the JSON collection, like JSON property info of T, like with new features, we can add those to the struct and then like initialize the metadata. So at least these APIs might be a little more stable. I think we might still have to like deprecate some in the future, but it won't be as like bad as it would have been if we left things as is. So moving down to another class of the APIs, just APIs to configure the source generator that users will interact with. So if we can scroll down a little past the collection info stuff.
Sorry. Scroll to the right or
scroll down. Sorry. So yeah, we have APIs to configure the source generator. So prior to this, we had a constructor that took two options instances. One of them was supposed to specify the options instance for the current context, and then the other was supposed to say what are the options that map to the design time specified serialization options. So rather than take both of them in the constructor, we just have an abstract property which like a construct, which context instance is supposed to override. So the source generator will provide this like override, so users don't have to worry about it. And then we also have this ignore runtime custom converters that say whether the generated source code should ignore converters at runtime. I initially added it because of like size considerations, so to avoid like a custom converter check. But I don't see a scenario where people would want this, and that check is going to be pretty fast because we can first look at the length of the collections converter list. So basically, we don't need this anymore because I don't think it's useful. And then that is all I had in mind for now. And I think there's some comments around from Steve about like some things we should do.
Sorry, I think I don't understand. What is the design time options?
So we have a mode with the source generator, whether we should generate like metadata initialization code or serialization logic. So the design time options are the map to what is specified with the JSON source generation options attribute. So like if you say the naming policy is camel case, this design time options instance will have the policy set to camel case, and the serializer uses that to determine whether we can use the fast path logic or not. So like we compare the options instance to say it's a one-time check at the start of the serialization saying like, hey, like this context instance, like does it align with the source generated code for like predefined logic? So just features that we specify with this design time attributes.
So I guess I'm still not quite sure what's the difference between options and design time options.
So options are whatever options that users want to use at runtime, like for a given context class. So you can say whatever an arbitrary like JSON serializer options instance, right? And that might differ from the runtime, the design time options that you specified using JSON source generation as attributes, which the class right below this JSON serializer context class. So
is it then fair to say that the design time options is not set by the user, it's basically emitted as part of the generated code because it's basically taken from the attributes that the user specified?
That's correct.
I see. So like So the reason why I'm struggling with design time options, so design time usually refers to things that run inside of VS on, in the designer surface or something, right? So like think of a forms control or a property grid instance or something. Like, and that seems confusing here as a terminology. Like I think what you want here is more like, I don't know, like I think instance options or static options kind of convey that a bit better, but I don't know that makes it better. Just design time usually refers to things that are running in a designer, which is not really what's happening here.
I don't mind static options. Just something that was specified ahead of time.
Yeah. I mean, statically typed options and dynamic options is another thing, but I mean, dynamic is also not great because it's overloaded. I guess runtime options and static options might be better as names, but
built-in options or build.
I mean, generated options wouldn't be bad,
Generated
right?
right.
Yeah, I guess generated options is probably the best one.
Generated options. They're only generated because you specified them. I think more interesting is the fact that you specified them.
They're the options to use when you're going to use the generated serializer logic.
Yeah.
I'm struggling for a good word to use to describe that thing, right? What do we call it? What do we call that in the API?
What do you call it?
Serialize. I mean, so we have a JSON source generation mode, and we call it serialization.
Yeah. Yeah, I think that these same options would apply to deserialization as well in the future.
Right. So if we called it source generation options.
Yeah.
Or source generated options.
That would be good. I mean, it's basically the bifurcation here, right? There's different runtime options from what the source generated serializer options are, right? And so we need to come up with a terminology here that is consistent, and because people have to understand that these are different things, right? And so I feel like, yeah, maybe calling it source generated options or something to that extent makes the most sense because you're very specific about what these options represent. Design time seems fairly hand wavy, and so is static or the other words you talked about.
Because I mean, it's pretty obvious what those are then, right? If you call it that, like these are the options that are used for the source generated code versus the options that are passed in on the constructor.
Yeah.
Yeah. I mean, generated serializer options is the only other thing that I've come up with, which because it's for when your serializer / deserializer was generated instead of is dynamically built with reflection. But all of the options sound a little off, and I don't know which one sounds the least off.
So what was the one that you suggested?
Generated serializer options. The options to use when you're using a generated serializer.
Yeah, the only thing I don't like about that one is that, the question is, is there a difference between the serializer and the deserializer? But hopefully not.
Hopefully not.
Right. Well, because using the noun form instead of the verb form, I guess I can also say dative and accusative and just feels super more German. The serializer is the thing that does both serialization and deserialization. But if we say, serialize options and deserialize options in the verb form, then that would apply to only one or the other. But
right.
The serializer is the thing that
That's
all
both.
serializer tech that I've seen uses to refer to the thing that can do both. Only if it splits, then it means one, and deserializer means the other. But if you talk about like the serializer, it's the thing that goes both directions, usually.
Yeah, I can live with both source-generated options or generated serializer options then. I mean, they both, I think, convey pretty specifically that these are the options that we basically hard coded into the generated code.
Yeah, because I mean they both have a secondary interpretation problem. Because source generated options also sounds like it's options that were generated themselves, and instead it's the options you want to use when the serializer was generated. So things are difficult.
Either one of those is better than design time options.
Yeah.
And even more better than default options that we had before.
Yes, I mean that's a good question from the chat. So why do we expose it at all? Like, what who is reading that and why?
Just that the source generator, so the serializer needs it and can only get it from, and it needs to be specified. So it's the source generator that needs to override this. So that and I mean the source generated code needs to override this, and it needs to be visible to it.
I see.
To that code. Yeah.
That's how we get it in our library. That's how we get what was specified in the attribute.
Yeah.
Right. And we need that to be able to tell, is the current options compatible with this one? If so, then follow the generated serialization path. Else fall back to the other path.
Sure.
Yeah, that makes sense. Yeah, I mean, pick a name, but I think you understand why design time options doesn't work.
Yeah. Oh, okay. Yeah. I'll just generated serialized options sounds good.
I had another comment. Can you scroll up, Jeremy?
It's emo today.
But,
emo. Sorry.
fine.
Stop. Down. There's one in here. There's one in here called create queue or stack. Sorry if you scroll down one more.
Oh.
Probably.
Yeah.
Oh yeah, create stack or queue info. Like, don't we know? Like, this is source generation. I would have thought we would know if it's going to be a queue or a stack.
We do know. It's just that would be specifying, like, would be creating two methods which would do the exact same work. So I guess that's fine because it's the same converter.
Well, we already
that
have
handles
two
them.
methods.
We
right?
have the two above it. Yeah.
Yeah.
No, those are for the generic ones. But this one's for non-generic.
Oh, this is for this stack, not stack of T.
Oh, it's the Oh, I see. I mean, honestly, I would just duplicate the signatures from the generic versions because it's easier to deal with that. I'd rather have two methods than this crazy one.
Okay. So it creates stacking for create queue info.
Just one's
And
of
then
two generics and one's of one.
What's the non-generic one, right?
Well, because this one is generic over the T collection, but not over the T element. So we'd have
Yeah, I think
create
that's only
queue info.
because that's only because it handles both, right? I would assume you can only ever instantiate with stack or queue. So that means
Yeah,
if
why do
we
we
put
need
it into
T
two
collection?
methods, we would not have T collection. It would just return.
Why do we
Yeah,
even need T collection on the generic ones above it?
The return type needs to be JSON type of T. So
Can
that
it be
users
JSON info of Q?
of Q, because it might be something that derives from Q, not Q itself.
Oh, because they're all open. Yeah, you can derive from them. That's true. Who does that? Only bad people.
It's more common than I would have thought.
Is there a where clause on the end of these?
Yeah.
There is, and the scroll bar indicates it's a bit of a mouthful for all of them.
Okay. Well, my questions are answered.
Yeah.
Actually, there are some questions around struct versus class for these.
Yeah. So how often are they instantiated? This is like just once at library startup, right?
Yeah, but we do care about app startup as one of the goals for the future. And I took some measurements where we, like, if we make them classes, would be allocating more than the dynamic part of the serializer for this like type info creation. I mean, more like not more overall, but just more in some specific part.
Like, I mean, it will allocate because you called new, but if you're calling it once and then you're done, and then the structs are basically, and Tanner or someone could correct, but the hand wavy is they're basically unpacked as if they were just an expanded list of parameters and passed that way. So you're still paying the cost of having a 23 parameter method, which is a very expensive call because the way that the data has to be aligned before the method call can happen. So passing a struct, if you're creating it a bunch and passing it into one thing, which is doing all the work and then you're done, then a struct is probably better. If you are passing it through like two methods, then a class was probably better. And if you need to put it in an array ever, a class is guaranteed better because you're bigger than the Jan Codis's suggested 24 bytes. Past that point, classes are almost always better. There are very few cases where a struct that big is good. If it has to be because of something like the ref struct JSON reader, then now you have a reason it has to be, but it's ref struct, so you should always be passing it by ref, which avoids most of those problems.
Ref struct doesn't mean you should always pass it by ref.
Fair enough. It's a ref struct, and the reader's just is complicated, and you should pass it by ref.
But yeah, I think Jeremy described it pretty well. If we had a struct that was bigger than 24 bytes, and it's not specifically a SIMD type, so if it's not one of the types that I'm exposing, then you should be passing it by ref. And even then, allocating a class is probably better. Especially if you're going to have like 23 parameters and stuff.
I mean, they're all singletons anyway, right? So.
Right, which means that the allocation cost is low, but the passing it through place to place is expensive. It's more expensive for a struct than for a class.
Yes.
How is an object better if you're passing the struct by ref?
I'll leave that one to Tanner.
I mean, you pass a pointer then, right? So it's basically the same as passing a class.
The only real difference between passing a struct by ref and passing a class is whether or not the allocation happens.
Right, so we wanted to avoid the allocation, which is the reason why there are structs.
Right, but is that allocation going to be a problem? Are you going to be doing that allocation many
field
times?
I mean, for every field. So if you have a Polka with 100 fields on it, 100 LX.
Why is that
That's
per
fair.
field? I thought it's per type
Or the
shape.
JSON property and so on.
Oh, because you need to have the getter and setter and all of that stuff.
Yeah. So it can happen, like this will happen a lot, could happen a lot across various types.
Right, but when you pass all this, it goes somewhere and does something, right? So you're holding all 23 pieces of information somewhere, and what kind of thing are you holding it in? How's it getting into that place? How many copies get made of it along the way? How many copies get made just when you try reading it? This is if the only number you're looking at is how many bytes got allocated when you called this thing once, then yeah, you're going to see a bigger number of allocation. But generally, your throughput perf is better for large things if they're a class.
Yeah, I mean, I think the choice to be here will have no bearing on throughput. It's all about start time considerations.
You have to. So if you're going to do a struct, you have to pass it by ref or in. In will make it immutable, but then you have to make sure that the struct itself is read-only, or that all members that you might want to invoke on it are themselves annotated read-only. Because trying to mutate anything will cause a copy. There's just all kinds of additional considerations which Jason's already aware of. because it's using ref structs everywhere. But
yeah, we do. So go ahead.
I was going to say, provided that, it's a struct, it's passed by ref, and it's always accessed and used by ref, then it will be no less efficient or more efficient than a class other than removing the allocation.
And these could be made ref structs, I believe.
They could be. I mean, we don't want to mutate them though. Like just immutable and pass by in was like the goal here. You're just giving us the information and we're reading it, and that's all.
There is a copy made. I mean, so we did discuss internally, like, should we expose property setters and getters on the underlying type that is created, which is the JSON property info of T internal class. But we decided that we want a layer in between that, and modifying the existing internal type that these structs are copied to expose setters like this is not trivial. And anyway, there's not a one-to-one necessarily between the two, so that's why we have a separate type here.
Yeah.
But to avoid confusion, I think making these ref structs instead of normal structs might be worth it.
So
Oh yeah, the struct doesn't need to be the ref struct. That was me misspeaking. You need to be a struct. If you need to be a ref struct, you need to be a struct. And then if it's a struct and you only pass it by ref, so the thing that you call this thing and then you build this struct and then you're passing it to a thing. If that took it by ref or in, then it's ref passing instead of value passing, which is the thing that will help speed up the perf. But then now you get all the complications of its, ref passing a struct. Just that it's super easy to accidentally make copies because it's a struct and other things. But the struct doesn't need to become a ref struct.
So a read-only struct passed by in, I think, satisfies like my requirements. Unless there's pushback on that still.
I mean, if you really wanted to micro-optimize, you can look at using a ref struct. I mean, the allocations are going to be on the stack probably instead of, they're probably going to be on stack in both cases, but it'd be interesting.
I mean, it would be good to measure, right? Because it seems like it's still a lot of data, right? So it's not like, and I mean, all these things have fields. I guess fields are properties, right? And they themselves are still classes, right? So the JSON type info stuff, but I guess those are all singletons, right? They are not. They're just per type, right?
Yeah, one instance mapping to a type. Similar, like one singleton. But so what was the OI trying to say?
So I don't know, like without measuring it, it seems like I don't know what to do here. But I mean, in general, I would say every time we have used structs, it backfired eventually. But I mean, they're all read-only, so maybe that's fine. But there certainly are usability issues with them. But I guess those are also not the types we expect anybody to actually interact with a lot. So again, maybe that's fine.
Yeah, this will just be used by the generator. I can do some measurements to see, like, ref struct versus read-only versus class, and but just my assumption of how it worked was that there will be reduced allocations, and because we're not mutating it, then we don't have to. There don't be copies.
Right.
So yeah, I mean, we do copy the values to the corresponding JSON property input, but that part is not changing because that's what we're doing with the previous approach of passing the parameters.
And that would be a good thing to just verify. Like, I mean, how much overhead you have here when you call these guys without passing them as ref, right? Because I mean, these copies don't seem cheap.
Yeah.
And
Okay,
given that
yeah,
this code is only used by the generator, I guess it doesn't really matter whether we pass it by ref or not.
Yeah, I mean, I will say that I will, after we finish looking at these, I will make a PR, like trying to get some parameterized constructor functionality in. So I'll likely go with like read only struct for now and then measure and then come back with like a change proposal. If measurements show that we should do something else. Or whatever we agree that we should do now as a placeholder. This is blocking like APR.
I mean, right now, with the way that it's a struct and you're passing it flat, like, it is worse than what you were doing previously, because you're causing the compiler to make sure that a thing is built and aligned in the right way in memory, and then we're basically exploding that at the call site. You can think of it as exploding. And then we're kind of reassembling it to because you're passing a copy of it instead of passing it. So there's a lot of forcing things to go in the right order that doesn't need to happen. And because structs have guarantees of talking about address layout, and yes, there was the discussion of auto versus sequential and whatnot, but like structs make things complicated in ways that classes don't, and they definitely make the perf more complicated in ways that classes don't. They are good for if you're building it in a tight loop and it's small and passed shallow, then a struct is good. If you build it few times and pass it a lot, then a class is always better. And so if you need to look this up multiple times, then a class is always better.
I think the primary goal of like with the struct or class is just the encapsulation of all of these values into like just the encapsulation rather than have them as parameters for like better forward compat. So I guess I'll circle back with the performance aspect of it.
I mean, go back to the previous approach, right? We had 12 parameters, and then well, we started out with maybe with 8, and then eventually went to 12. We're thinking in the next release, if we add another one, now we basically have a method signature that's only used by older, already compiled.
Yeah, I agree with the object encapsulation of your parameters here. I just think they should be a class.
Okay, well, we can take it offline when we show the measurements. I mean, really, is to avoid the heap LX, and we're going to pass it by ref, and only like probably a single hop, and it's and more or less all of these types, for the most part, I think, are essentially, we consider them internal, but we can't make them internal. We don't expect people to use these.
Yeah.
It's a lot of pop-ups, Simo.
Yeah.
Was there further feedback? Questions?
I think this was pretty much it. I think the conclusion here is needs work, right? And then I think we gave a bunch of feedback. And then that's pretty much it. Let me just paste it.
Do we have suggestions on the names for like CTOR and func and
I would just expand it. Constructor, property, parameter. And then for func, I would go with handler or callback.
That's not a callback, right?
Well, it kind of is, right? I mean, you set
For
it
sure.
to some func.
Like this is like the factory, right? Like this is the thing. Like it was like in when you have a collection and you want to create a new element to start setting stuff into, like a collection, like a list of customer. It's like this is the callback to create a customer. I think that's kind of weird to say it that way.
I mean, it's the library is calling back into caller code to
Yeah.
compute a thing. That's what the callback means.
Okay. I would not use callback for those.
I mean, I'm fine with handler. Like, I mean, I don't. I mean, we've also sometimes just use the term factory, right? If it's very clear that it's only used for instantiating stuff. But it seems like in your case it's a bit more complicated, right? Because you have a getter, you have a setter, you have like, some stuff is like kind of clear what it is, right? So.
Right. Those don't need. I don't think those need a suffix.
Yeah,
But
I think getter and setter are fine for those.
I think that's pretty obvious, right?
But in the case where we have something func,
yes.
like create object func, prop init func.
When we just create object, well, no, never mind.
So
Prop init callback might actually make
object
sense.
creator, right? Like it's you just need to nounify part of it.
You call it just object factory.
Yeah, value factory.
Yeah.
Feedback is don't use func.
Yeah, don't use func, don't use abbreviated names. I mean, init is kind of fine because that's what the keyword is called, I guess. But like the, param we don't use, right? Citra we don't use. Func we don't generally use.
But properties don't have initializer funcs. They have a setter that's just a set. That's a set with an attribute on it that the compiler says can't be called outside of the object initializer.
I guess that depends on how, like, what's the.
No, they explicitly chose not to create a new slot called a init. They went with set.
No, I know, but like that was. I mean, that's kind of. I mean, to me, there's a difference between what you see in C# and how it's encoded in metadata, right? Like that's what I'm saying. To me, you can go either way. It depends on what semantics you have attached to what the prop thingy does, right? If you want init behavior.
But it seems weird that like we would encode that something says init unless we actually care about that, because it seems like it's probably just actually being I just need the setter. So it's just the property setter.
Yeah, that's fair. I mean, you also have param init, which doesn't really make sense. So I guess don't use init, I guess is the takeaway.
Yeah, just clarify what those funcs do, like. So it basically helps us like lazily create metadata for JSON property info and JSON parameter info. And that's when we're not using the like fastpath serialize method where the serializer needs to understand like the types so that it can use its own logic.
Yeah, I think the funcs themselves make sense, right? We just debate the names, right? It's just the give it names that are not like.
I just wasn't sure whether we're mapping the init in the name of the variable of the property to like the init of the setter.
The type of the property is good. The name of the property is what we're upset about.
Right.
I had one quick question that came up before around the serialize method on the JSON typing for T. So the reason why we made this public initially was because so that users could call it directly, thinking that there might be some performance boost over like the serializer calling it under the hood. From measurements, it's not the case. Like they perform just as fast because we get to that code pretty quickly in the serializer. I think one benefit of exposing this is that more of the system text JSON can be trimmed out if you call that method directly. Are there any thoughts about whether we should expose it or not? I guess one more consideration there is like there's a try, like the serializer has this try catch. Actually, I think we can split up, but just a question of like the only reason to have this serialize method public to the surface is that it allows more of system text JSON to be trimmed out. Like, is that something we should keep? We can have this internal and only the serializer has access to it. So everybody that wants to use generated like serializers will need to go through the serializer if we remove it. Any thoughts on that? If not, then we can leave it. or maybe something that we can delete.
Sorry, I took notes, so I didn't actually hear the question.
So JSON type info of T has this serialize method, serialize action. Do you see
So
the
JSON type info. Yes, it has a
On your screen
CLS.
about 2/3 down.
Yeah.
has a serialize method? So this is basically like an action that the user can invoke, that they pass the writer and the type
Mm-hmm.
and the instance, and then we can call that fastpath method directly.
Mm-hmm.
So at first it was looking like that would be faster than going through the serializer itself, which essentially does the same thing under the hood. But from perf measurements, we see that there's no like difference. Like it's just as fast calling this directly versus passing the type info instance to the serializer to do it. So
I would
I
honestly
think,
remove it probably then.
yeah, the only benefit is that we can trim more of the serializer because we don't go through the serializer.
Oh, I see.
So it's something that we can expose in the future if we wanted to.
Is there any reason why this is an action? Why is it not just a method?
Because we can easier detect whether like it's supported or not, like whether like there's an implementation or not, as opposed to having like a boolean saying like has serialized func, which you call first.
No, I meant like, why is this thing returning an action rather than just be literally a method? Because I mean, the way the user will use it is just they just do type info dot serialize open paren, right?
So I think like if it's like a virtual method that the generator provides an
Well, it doesn't
implementation
have to be a
for.
virtual method, right? It could just be. I guess you need some sort of data, right? But I mean, given that this is a get only, clearly you have some sort of internal mechanism to set it today, right? So it could be a private thingy that happens to be an action, right? But why does the public API have to return an action? That just seems odd. If that makes sense.
What's a good, like, I wonder how else we could do it.
You have a public method that takes a UTF-8 JSON writer and a T.
Yeah.
And then we call that under the hood.
And then internally that public method calls the action that gets set by somewhere.
For the case that you only generate metadata, would this thing throw then, or what?
It would
probably
throw.
I mean, it would throw null ref if you tried to dereference it.
Well, I mean, if you had a method, I mean, you put an implementation there. This is not supported exception or something.
That would be what we would have to do.
Is there scenarios where you want to check if this thing is set?
As a caller?
Yeah.
I mean, so maybe we need to document it, but there's some cases where you might say, I want fast path logic for a type, but we will ignore it because it's not supported. Like you have like dictionary of objects to, like anything that has object in its object graph, because it needs some extra polymorphic support to like do that detection. We're not doing that for 6. So there's some cases where like you might want to check, because
I mean,
it's not guaranteed there.
We should probably not call it just serialize. Because I mean, to me, the expectation would be that's always there. The fact that it's nullable is odd. I mean, sure, people that have it enabled will get a warning when they just try to invoke it, but it's not obvious to me what I would have, like, why would that be null kind of thing, right? So I don't know. Basically, I would expect a name that kind of conveys that it's a serializer that doesn't support everything, right? I don't know. I mean, fastpath serialize is not great, but it kind of conveys that, it's not just a generic serialize method, right? So it only works for certain things.
Yeah, I was kind of relying on the nullability to suggest something, and then maybe documentation.
Liam, you said earlier that this is can be optionally exposed, right? We can add this later if we want.
Yeah.
Because we already pass in this func when you initialize it. And I mean, the serializer knows how to call it if it needs to.
Yeah. Just be internal.
What? Okay.
So yeah, it's like, size. Do we want people to trim out more? We do. There's one change that we need to make to the internal serializer thing, which is to add like a try catch for like some exceptions that might be thrown. So if you go through the serializer, we should be doing the same like exception handling. I'm not sure. I don't think that will add a lot of overhead to the point where like it makes this func faster. I guess that's something I do want to confirm before actually moving it. Like if the extra like exception handling stuff will present a case where like it's faster to call this func, but I do not think so far. But I will. So my play to make a PR that confirms that, or like do some measurements. So I mean, despite this discussion today, I might come back and say, hey, I think this actually value because it is like non-trivially faster than going to the serializer now. And we'll think about like tech and power benchmarks and whether we need to rewrite those using this action. So I guess the question is, so if we do expose it, is this the right like way to expose it using this action, or should we create a method that calls this action or detects it?
I mean, honestly, like it might be better to just have literally a regular method that returns void and then have an exception that tells the user what's wrong.
Right.
Because I mean, like, I don't know. I mean, you can argue that that's unfortunate because now you have to check up front. But I mean, you could just imagine that we have, I don't know, fast serialize and can fast serialize, right? And then the can fast serialize would just return if the underlying action is null or not, and the other one just does the thing, right? Because I mean, the programming experience might be slightly better when you do that. To me, the nullability is just very subtle. It's kind of like it's null, but why? that doesn't seem obvious, right? And if mass majority of people just ignore it, they just do the typical $.invoke kind of thing, then you also defeat the purpose, right? Or I guess, yeah, I mean, it depends on what semantics you want, but it seems weird to just not call serialize at that point, right?
Yeah, I would certainly like tell them all the cases why it would be null.
I mean, my question is, if I'm using this and I compare this with null, what do I put in the else? Is that obvious?
Else called the serializer.
Right, but is that obvious to the caller? Like the property is null. Is this obvious? I mean, it's obvious to me that I should check that it's null, but it's not obvious to me what code I would do in the else. And the nice thing with an exception is you can actually tell the person what to do, right? So you and the downside of exceptions is that they are somewhat more expensive potentially, but you don't really expect anybody to write a catch handler for this. You expect this is what would be a programming error, right? The idea would be, no, you need to check the can fast serialize, and if the answer is no, then you call into the regular serializer, and if the answer is yes, then you can call fast serialize, right? That would be the way you expect people to write the code.
Yeah. I mean, I initially thought of it as like this is maybe like an advanced like performance scenario where like you have to know what to do, which I think was the attitude we started writing the serializer with. Like, in some cases, like
I mean, that's fair, but that's also not what the blog post says, right? The blog post kind of says like, well, you have an option here. You can call this method, or you can call through the serializer, right? So it's more like an aesthetic design decision almost, rather than it's an advanced scenario, right? And that's kind of my concern, that people will just do that and they don't have nullable enabled, and then bad things happen, right? And then they have no idea what's going on.
Yeah, I just don't think that the blog post like mentioned everything about the feature.
No, I'm just saying it's an example where you can see the way we wrote about it is kind of, it's like even ourselves, we haven't positioned it as an advanced scenario, right? That's why I'm saying I'm skeptical that people will think of it as an advanced and just say, oh, it's cool, I can just do ... serialize and then stuff is happening, right? And that might work for some cases and suddenly it stops working for them. but they have no idea what's wrong because all they get is a null reference exception, and then it's like, clearly that stuff is not ready yet, right? So the takeaway isn't I did something wrong. The takeaway is the library has a bug, right? Which is also, if you throw your own exception, you can tell the person you're holding it wrong. You're supposed to check, and here's what you're supposed to do, right? So that's kind of from usability studies, we kind of know that exceptions are almost always better than trying to use the type system, because the type system is static in nature and you can only express so many things. And if you want to tell the person what's wrong, it's very hard to do this in the type system. You can only do this for cases where it's obvious what's wrong, right? But like for cases where it's not, it's like a combination of things that you have configured that don't work in conjunction. Throwing invalid operation exception with an actual message that explains that to people is almost certainly resulting in a better user experience. And this could be the case here as well, right? Where you just say, this is fast path serialization, which may or may not be supported based on the shape of your types, and you're expected to check for that, and then in the else clause just go through the regular serialization method that has more overhead potentially but will work. And so I think that's kind of where exceptions would probably be more helpful than just, oh yeah, this thing can be null.
Right. I wonder, so if we had a method, would we, if it's null, call the serializer? Passing like the type before,
and that's
or
another
would we just
option
do
we
an
have,
exception?
right? We can literally just say, we can just make it work and say we will do the right thing. We try to be fast, and if fast
Well,
isn't
actually-
possible, we just do the regular thing.
But that might lead to another exception if you don't provide the metadata, like
Right, but that
which might be more confusing.
well, maybe not, right? Because you can argue that that's an easier fix for the customer. You would just tell them like, hey, the shape of your type cannot be serialized unless you include metadata. So configure your options to include that, right? And that would be the fix, right? Because if you need to serialize this thing, you need to serialize this thing, right? Like your option is not to not serialize, right? It's just like I would like to have it fast, but if fast doesn't work, well then slow it is, I guess. And if slow doesn't work because you're missing the data for it, well then I have to include the data, right? So it's not like I don't know. It doesn't seem like the option of not serialization is really viable for the customer, right?
It just seems a little, because I'm not yet sure what the signatures for the serialization will look like.
Well, it would be looking the same, right? Serialize would return void. It would take a writer and it would take a t value, and then you might throw an exception that tells the person, sorry, you have to include metadata, otherwise we can't serialize this thing.
You're either going to have metadata or code for the serialized method, though, right? You can't. I don't see how you can.
Yeah, still we have neither.
Okay, so another question on this related is, when one POCO has to call the serializer for 10 other POCOs, I'm assuming that those 10 methods it generates call this method. Is that correct? It doesn't go back to the serializer.
Yeah.
So so you need this method for code gen or source gen.
Well,
so part of the problem is it's just not easy to remove, and people still can see it. In other words,
actually, yeah, that
see.
is true. Yeah, it's needed. It's needed for code gen, so we shouldn't remove it. Like maybe we can discuss. We can discuss if we should refactor it, but it needs to be visible within the source generator, like public on different type of code. But the source generator itself knows whether the other like serialized methods will be not null, because it's generating everything. So like the usability improvements wouldn't be for source gen itself, it would be for users. But yeah, that's a good point about like us needing it. Unless we do like call the serializer, but that way I guess we're sacrificing. I think it will eventually show up. Like, so overall, yeah, we could, instead of calling the serialized methods directly, we could go to the serializer just like users. But that just seems like we're not being as fast as we, on paper at least, not being as fast as we can.
Yeah, but it seems there's no other alternative, right? So to me, the problem is, I mean, what you don't want to do, generally speaking, is you don't want to fall back if the customer can just write different code and have it faster. In that case, sometimes it's better to just fail and not make things work, to actually tell them like, yeah, you should write the code differently rather than having these silent perf traps. But if the alternative is stuff works or stuff doesn't work, well, if the expectations the user would have to write the same code that we could just basically do for them, it's better to just do that, because the why would you fail something and say, oh, don't call this method, call this other method over there, right? If you could have just called that method for them in the error case, right? Because at that point it's just like, well, if you want me to serialize this thing and I can't do it via the fast path, well then I guess slow path it is, because you would ask the person to call the slow path anyway. But the nice thing is, if we do it for them, they can always call this method, and we will always prefer the fast path if it's available. So it's generally for them, it's better to do that than always go through the slow path just in case. So like if you think from a customer standpoint, if some methods throw sometimes or work sometimes and sometimes don't, eventually I just stop using this thing and just always go through the other thing, because that at least always works. But now you're teaching people to always do the slow thing, even though the fast thing would have worked in maybe 80% of cases, right? So in that case, it's better to just say, always call this thing. We will prefer the fast path if we can make it work, and if not, we fall back on the slow path. So it's a net win to use this method, basically.
Just to confirm, Leomi, there are no like subtle behavioral differences between the two methods, correct?
No,
between the two techniques. Okay.
Yeah, we have to saying like they should always do the same thing. Like,
well, no, there might be some exception handling.
Not if you go through the serializer, at least not after I make that change to the exception stuff. Yeah.
Okay. That's actually a much stronger case for Emo's argument then, because I know in the past, when we have had multiple different ways of doing something, they have had subtle differences between them that would perhaps make one technique not appropriate as a generalized case.
Yeah.
But I think Emo makes a very compelling argument, though.
And I do like that, and it also avoids that if check, because if we generate this with the call as a slow path, there is no if check. It just calls it because it knows we didn't generate the code. So I think if I'm understanding right, we can avoid the if check altogether.
Well, the if check would be inside the method rather than at the call side, right?
Well, I'm thinking if we don't generate the source code, it just calls in the serializer. There's no if check necessary.
Well, you wouldn't emit the if check, right? Because it's not at the call side anymore, right? It would be inside the method to say, do I have the fast path, or do I have to go through the slow path, right? So
at
runtime
we know
happens, right? So
we know whether there's a fast path or not because we're generating the code for this.
Yeah, fair enough.
Yeah, but in that case, so to be clear, the suggestion from Vivo was to have a void that takes the right and the T, and then within the void do a null check. Was that the one
Pretty
where
much,
we seem to be
yeah.
converging on? Okay, so the search generator would know that the thing exists, but the null check will still happen because the implementation will do it regardless, right?
I mean,
even though like
so another option you have is you can say the serializer calls into a different method that would not do that, right? But and I understand you may not be able to hide that because it needs to be a public API that the generator can call, but then you would just give it a slightly less attractive name, right? I think the problem today is that this looks like if I want to serialize this thing, I can just call this and it will always work, right? And the answer today would be no, it wouldn't. It would only work for a certain shape of types, and that's the confusing part, right?
I mean, that characteristic will go eventually. Like it will be more like it will be more uniform, like regardless of your when we start supporting polymorphic cases. I guess it's just a point in time thing for right now. I think even like primitives like integer and like string, although it's like a little weird, but we can have a fast path for those, so it could actually be never null eventually. Like assuming that you specified like serialization source gen.
Okay, so we're 17 minutes over now. I think we need to end this, but I think like think about what to do here. And I mean, I think we gave enough feedback to, something needs to happen here, I think. Make a design decision what to do with it. I don't think we know what the perfect answer is, but we know that, it's in the ballpark. I mean, I think it looks good, except for the feedback that we have here. So I'd say, let me just click comment on this one, push this back with API needs work, and then, let us know what you have planned for this.
Sure. Thank you.
Alrighty, so then this is it for today. Then thanks everybody. And then I see you either on Thursday if we need to do an emergency one, or otherwise it's Tuesday.
Sure.
Toodles.
Thanks.
Bye-bye.